Chapter 15, Acids and Bases. One of the interesting things about Chem 1A is that we just don't really talk about acids and bases very much. And yet in Chem 3A, we talk a lot more about them. Well, here is the makeup for what's lacking in Chem 1A. So the book talks first, they've got I think this is supposed to grab your interest. I don't know. It's somewhat interesting. So sort of an application, heartburn. I think we've all at least heard of heartburn, if not experienced it ourselves, also called acid reflux. Very common problem. There's hydrochloric acid in your stomach. And for various reasons, that hydrochloric acid can back up into your esophagus, which was not intended to be bathed in hydrochloric acid. And you get this burning sensation and sometimes just this really, really painful sensation because the HCl irritates that lining. And if it's really bad, it can actually come up into your throat and into your mouth, and you get that nasty, sour taste. And it's like, ooh, I threw up in my mouth a little bit. You know, when people say that, that's that wet burp thing that happens. It's really, really disgusting, right? I call it a burp. You call it a verp? That's excellent. I like that, verp. It's a vomit burp. I hate those. So what does this have to do with chemistry? Well, your saliva has bicarbonate ion, HCO3-, which acts as a base and can neutralize that acid. So if your heartburn is very mild, just swallowing repeatedly will help to neutralize that acid that's come up into your esophagus and soothe it a little bit. My experiences with heartburn when I was pregnant with my children was that even serious antacids did absolutely nothing. But antacids are more effective because they contain a lot more base than your saliva does. And so they can neutralize that acid and help to stop the pain. The pain is only part of the problem because it actually damages your esophagus.
Does the saliva act as a bicarbonate buffer?
Yes. Yeah, your body has a very sophisticated buffer system to keep the pH of all your tissues where they're supposed to be. Very interesting. And we're going to talk about buffers and how they work. GERD is gastroesophageal reflux disease, and that's when heartburn gets chronic. And some people suffer from that. That can be caused by a number of things. But they can actually diagnose that by placing a pH sensor, a little wireless pH sensor down near the bottom of your esophagus, and then it will transmit pH readings. And so they can track what's going on in there during the day and then find a way to treat it. So there are acids and bases in our everyday lives. There are acid-base reactions going on within our bodies. Acid-base chemistry is important when you consider medicines. You know, if you have a medicine that will decompose or react unfavorably in an acidic environment, then you don't want that dissolving in the stomach where there's lots of acid, and so they'll put coatings on it so it goes through into the intestine and can be absorbed there. And there's all sorts of applications of acid-base chemistry. And then if you study biochemistry or molecular biology at all, acid-base chemistry is very, very important in the chemistry of living things. Amino acids are very important. Those are the building blocks of proteins. Amino acids are acids, right? And your DNA and your RNA contains bases, A, D, G, and T, right? And U. And those they're not just bases like, oh, you know, put a bunch of bases together and we get this city or something, I don't know. They are actually bases in the sense of acid base. So there's your general interest section.